David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember that you can adjust the playback speed as you desire. Second, you can pause the video at any point to jot down notes or write down questions. Third, you can turn on the captions so you can read my words on the screen. Today's lesson covers mathematical modeling with derivatives. And contrary to what people might think, mathematics wasn't invented to give high school students grief. Mathematics was found to explore natural phenomena. So this is a situation where it could have happened, and it's a sales or it's a manufacturing example. So let's take a look. Daily cost of making helmets. So this is a helmet factory. It makes helmets. The total daily cost as a function of x, that's the number of helmets made, is 600 plus 7x minus 0.0001x to the third. Okay? So that's a cubic function, and it's going to model the total cost for making helmets. So x is the number of helmets, and c is the total cost. Okay, your first step is pretty straightforward. Find the daily cost if no helmets are made. And I realized I wrote total cost here. I corrected that. That should be daily cost, so fix that in your notes. So how much is the daily cost if no helmets are made? So pause the video and do that. So no helmets are made, that means the x value is 0. So if I put 0 in for x here and 0 in for x there, those two terms go away and we have $600. Now, think about that. We still have a cost if we don't even make helmets because we're paying people, we're paying rent on the building, we're paying insurance for the machinery, all kinds of stuff like that. So that's like a fixed overhead cost. So we do have a daily cost even if we don't make any helmets. Okay, we're going to dive in and I need to explain a concept that comes from economics. The marginal cost is the cost to make one more helmet for a given amount of helmets in production. And here's the idea. If I have a factory, I have economies of scale. So up to a certain point, if I make more helmets, it's going to cost less per helmet just because I can run the machine a little longer, but my rent doesn't change. So there's a lot of fixed costs that get spread out amongst more product. So the cost per unit is going to go down for some time while I'm increasing production. So that's called the marginal cost. So I want to show you on a graph how that might look. Okay, over here is our cubic function from above. In case you're wondering why it doesn't look cubic, here's what the function actually does. Okay, so we only need it for when x is 0, making no helmets, all the way up to making 300 helmets. Okay, so it is a cubic function, we just don't need all of it. And in fact, you would have a range here where you'd say 0 greater than, less than, equal to x, like that. Okay, that would tell you the range of the function, and you wouldn't graph this extra bit. So let's get rid of that. Okay, so the marginal cost is the slope of the tangent line at some point. So you can see that marginal cost is going to get less and less and less because the tangents are going to have more and more. The slope is going to get less steep, less steep, less steep until it starts trending downward. Okay, so we need to find the marginal cost function. Let's put that up. So this will tell us the per helmet price or cost for any number of helmets produced. Okay, so think about what you learned about this chapter to find the instantaneous rate, the rate of change at a point on a curve, and then you can do that process, take the derivative to this function, and you're going to get the marginal cost function. Pause the video and go do that. All right, so this is the marginal cost function. So if I make 20 helmets, I can just put 20 in for x and do that, and this is going to give me the per helmet cost. All right, let's put our function to use. Here's our function, daily cost. Here's our derivative of that function, which is the marginal cost. Okay, so the first problem, what is the marginal cost to make 20 helmets. So pause the video, I know you can do this, and come back with your solution. This is a straightforward plug-in. I just plugged 20 helmets into my derivative function, 7 minus 0.0003, 20 to the second power, plugging in my x, and that gives me 6.88. Okay, let's take a look at that graphically right over here. Okay, so I drew a new line on our daily cost function at 20 helmets. The tangent line is right there. So the slope of that tangent line is 6.88. Okay, what I want you to do is find the marginal cost to make one more helmet from this one. So pause the video, do a plug-in step, do your calculation, and come right back. Okay, this was just like this one, except I plugged 21 into our derivative function. I do my math, and I get 6.87. Makes sense. We made one more helmet, so we're going to spread that fixed cost over more of our product. So this one's going to cost a little less more to make than this one cost. And indeed, what we've done is we've slipped up this curve a little bit, so now the tangent doesn't have quite as steep a slope as it did at 20. Now, the cool thing here is that we can confirm that we go from 6.88 to 6.87 by using the cost function. This is the total daily cost. So pause the video, think about how you might want to do that, and come back. All right, so the total daily cost, all I have to do is calculate the total daily cost for 20 helmets, and then calculate the total daily cost for 21 helmets, and subtract the 20 from the 21, and the difference is that marginal cost. So that difference should equal this. That's the marginal cost when we went from 20 to 21. So here I've set that up, the total daily cost. Now I'm using the regular function, not the derivative function. And here's my plug-in step. I did the calculations and I get 739.20. So that's how much it costs total to make 20 helmets. Now for 21, again, the plug-in step, I get 746.07. That makes sense. I made another helmet. It should cost a little more total daily cost. Now, if I subtract this one from that one, I get the marginal cost going from 20 to 21. And if you do that, your answer is going to be 6.87. So we confirmed what we did with the derivative. Now, I hope you see that the power is that if you use the derivative function, you can calculate the marginal cost at any production level with one calculation. If you could do it this way, but then you've got two calculations, you have to subtract one from the other. This is more elegant. Now that you've watched the video, take a moment to jot down additional notes, some questions for class, or a short summary of the lesson. You can also go back and re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.